We have now seen what SI units are and why they exist, but it's also important to have a decent understanding of where they come from. There is pretty much an infinite number of physical dimensions in science. We've got joules, newtons, ohms, volts, coulombs, farads, henrys. The list just goes on and on and on. It seems like it would be impossible to keep track of them all, but you would be pleased to learn that almost all of the units out there are considered derived units, which basically means that they don't stand on their own. Those units are defined in terms of other units. For example, the SI unit of speed is the meter per second. As you can probably tell from the name, this quantity is based on the unit of length, the meter, and the unit of time, the second. This means that the meter per second is considered an example of a derived unit, or a quantity that is derived from meters and seconds. Some derived quantities are so common that they're given special names. For example, power is a dimension defined as a change in energy with respect to time. So 1 unit of power is then 1 unit of energy, the joule, divided by 1 unit of time, the second. So when we take measurements of power, if you want, you can say joules per second, and that's perfectly valid, but typically we don't refer to units of power this way, because power is so common that 1 joule per second is given its own special name, the watt. And this doesn't change the value at all, just remember that 1 watt is exactly equal to 1 joule per second. Of course, that's only one example, though. We'll talk more about power in a later video. Units such as meters and seconds are not derived from any other units because they're so fundamental that even their strictest definitions can only be decided by convention and what scientists decide would be most convenient. These quantities are known as base units, and there are currently only 7 of them in existence. I've listed them out here, but if this table seems overwhelming to you at first, don't worry. If you're brand new to physics or science, you can start by just focusing on these top 3 right here, the second, the meter, and the kilogram. The vast majority of units you'll face at first, especially in mechanics, are based on these 3, and chances are you already have a pretty good understanding, like a pretty good intuitive understanding of the concepts of length, time, and mass. We can just learn the other base units gradually as we go. Since base units don't have the luxury of being derived upon formulas of other units, the technical definitions of these things are pretty complex and specific. In order for measurements in scientific labs to be consistent and reproducible, these units are most useful to scientists when they're defined in terms of other constants or other physical quantities, known as standards. It also helps when they're readily accessible. The meter, for instance, is defined in terms of the speed of light. It's the distance that light travels in 1,299,792,458th of a second, and which is pretty yikes. Needless to say, I do not expect anyone to try and memorize those definitions, because it's not really important to know them all, but it is important to just be familiar with the fact that even the base units do in fact have their own special, precise definitions. And those definitions can sometimes change, too. Up until 2019, the kilogram was defined to be an amount of mass equal to the mass of an actual physical object that's held in a vault in Paris. This was a pretty bad definition, however, because its lack of accessibility meant that scientists couldn't easily compare it to their own mass measurements without having to use replicas and replicas of replicas, which may have eventually become slightly inaccurate in some way. The current definition of the kilogram is now in terms of the Planck constant, which, like the speed of light, is another physical constant with a set, unchanging, exact defined value. If you're curious about all the detailed histories and previous definitions of each of these quantities, you can pretty easily find more information about all of them online.